Yeah, good morning. Now I'm going to explain you a first program of your lab program in part A, that is the distance vector routing protocol. Now, what is actually the distance vector routing protocol? I have explained you in a theory class. Now, again, we'll take a look on that what actually the distance vector routing protocol. Mine, the path should be there from a source to the destination where to send on a packet. You know this, and a routing must be done. What do you mean by a routing? The packet must be traversed from source to destination via different nodes in a shortest path. So how to make this? There are different algorithms for a routing from packet from a source to the destination. In that, the distance vector algorithm is a one algorithm. What is this distance vector algorithm? Each and every node which is participating in a routing will have an routing table or a forwarding table. What is this routing table and a forwarding table? The routing table and a forwarding table is a one in that from that particular node to the other nodes, what will be the distance or an a cost will be taken into the consideration. So how that particular cost will be taken into the consideration. Initially, from that particular node, how many nodes are connected? For that, what is the cost? It will be entered in a table. If the node is not connected, then it will be entered as an infinity. Now, in our programming infinity, we will consider it as an 999. Why? It's a huge number of an cost. So we'll keep that in a sense. Now, what happens afterwards? Each and every node, whatever which is participating in a routing, will exchange its table informations. That is, the node which is connected to the other node and the node which is connected to the other node, like this, they will exchange the routing table information or on a forward table information. Then the node, what it will do, taking that table into the consideration, it will update this particular table. How it will going to update this particular table means whatever a table that has been came from the other node, in that it will see each and every node and it will see the distance, and whatever distance already there here will be compared with that particular distance. So once if the distance whatever already existing is greater than the value or in a cost in a updated table, then what it will do, it will replace that particular value in its particular. Why? Because it's a shortest one. So in a shortest it can particularly it can move. So in this way the distance program will work. First in a painting we'll see how this particular thing will work, taking one topology into small topology into the consideration. Now I will share that particular concept, that is share the window, right? Now I'll go to the point. Now share it. Now observe here, I will take one small topology, and taking a small topology, then I'm going to explain you. Assume I will take a node, for example, I will take a zero node first, and I will take the one node, right? And I will take some node number 2. Okay, then I'll take the node number 3, just for a sec. Now assume there is a links like this, right? No. Right. Now I'll write a cast here. First, let it be 1, let it be 2, let it be 1 again here, let it be 3, and let it be 2 again. Right. Now you observe carefully here, for example, assume how the initial table will be there in O means a 0. So in a zeroth node, how an initial table will be there. Now a zeroth node, what we are going to consider, first we are going to consider uh, here first thing is distance right? Another one thing is from which node that the distance is there. From right, in program it's like that, that's why I'm writing. Right, now assume for a 0th node I am going to take this into the consideration. From 0th node, the first is a first sorry, this is a node also I will take here. Yes, node number 1. Now node number 1, the distance whatever is there here, you can see, just I'll take here also. Yeah, go back. Yeah. Now for node number 1, the distance is 2. Directly it has been connected. You can see that, right? And from which node it is there? No, via node is there. Directly it is 1. Now coming to next node number 2. From 0 to node number 2, what is the distance? You can see in a figure, that is 1, and there is no in between node is there. From it will be same of that particular node. Coming to next node number 3, which is there. Now observe carefully, the 3, there is no direct connection from 0 to 3. Right. So initially, that means your 0th node doesn't know that in a topology there is 3. Okay, so now what initially it will do for a 3, it doesn't know that. So distance what it will take as an infinity. Infinity, right? So from which node it doesn't know, from which node it has to move. There is no direct connection. Now that is the initial table of that particular node. Right. Now coming to the next thing, the final table of the oath node. Right. Now assume the same fields will be there here. The node number, right? Node and the ds, and that is distance, and from which node? From which? Now what we'll assume like this, both 1 and 2 as sent a table to the 0th node. That is, if one node has been sent, assume, just we'll go with a one node. In a one node, assume first it will be sent its particular table. Now in a one node table, you can observe carefully, means comparingly, you can observe carefully, the distance to the first node, that is 0, is 2. The distance to the second node is 1. And the distance to the first node is 3. Right? Any doubt is there here? You can think. So here the one node, the distance to that is 3. This is a table of a one node which has been came to the 0th node. So once it has been came to the 0th node, now what 0th node will do, from 0 to 1 it's already 2, it will take that into the consideration, plus that the remaining thing will be taken into the consideration. Now the first thing is like this, whenever the one node has been came into the thing, that is from 1 to 0 it is 2, from 0 to 0 it is always 0, so it will neglect the first value. Now node number 0, so it is 1. Now coming to the 1 to whatever a 1 is there here, 1 to 1 it is 0. Assume carefully, 1 to 1 it is 0 always, but 0 to 1 it is 2. 2 plus 0 is 2. Now come to the existing table. Now in an existing table, 2 is there. 2 is not greater than 2. Now existing value, that is 2, is not greater than 2. Now what it will do, it will remain as it is, the value whatever is there of that, that is 2, and from 1 it is directly. Coming to the next node, 2. Now according to the table, initial table here, you can see the cost is 1. From via it is 2 only. Now it is 1 is there here. 1 to 2 it is 1. But 0 to 2, 0 to 1 it is already 2. That is 2 plus 1, it is 3. Are you getting my point? So 0, 1, 2. That is 2 plus 1, it is 3. Now 3 will be compared with 1. 1 is greater than 3. No, it's not greater than 3. Now what it will do? It will retain the same value. That is 1 and from 2 only. Now observe carefully the next value, that is 3. Now via 1, very important here, via 1, now again it will compare this. So from 1 to 1 to 3 it is 3, but 0 to 1 it's already 2. 2 plus 1, 2 plus 3 it is already 5. 2 plus 3 it is already 5. Now 5 will be compared with via 1. If you move to 3 from 0 it is 5. So 5 will be compared with 999. 999 is greater than 5. Yes, 999 is greater than 5. Then what it will do? It will take that distance into the consideration. What is that distance? That is 2 plus 3, that is 5. Via which node it has to go? Via one node it has to go. So the table will be updated. Now it is not a final table. Until all nodes will give the table, it will be taken into the consideration. Now assume again 2 is the other neighbor which will give a table to 0. Now when 2 gives the table, now observe 2 here. From 2 to 0 it is 1. From again 2 to 1 it is 1. And 2 to 3 it is 2. Now again I will write here. So again the table will be updated from 2. This is from 0 table is updated from again from another table. That is this distance, and this is from. Now you see here again I will come. Now coming to 2 to 1, 2 to 0 it is 1. Now 0 to 0 it is 0 always. So it never takes that into the consideration. Coming to the first node, observe carefully. Now first node, observe here, observe. Already this is the existing one now. Now this table is updated by this, and this is the existing table now. Now 0 to 1 it is 2, direct it is there from 1. Now via 2 if you go to 1, what happens? 1 is there already, this you have to consider. 1 plus 1, that is 2. Now 2 is greater than 2. No, 2 is not greater than 2. It's not greater than or equal to. 2 is greater than 2, it's not. So then 2 is not greater than 2 means then same value will be remained, that is 2 from 1 only. There is no need to change. Coming to the next, again 2, the second one. Now observe in this particular table, now 0 to 2 it is 1, and 2 to 2 it is 0 only. 1 plus 0 it is 1 plus 0 it is 1 only. Now it will compare. 1 is greater than with 1? No. Now existing is enough for us. So that is 1 only, 1 and from 2. Now observe the change here. Now 3. Coming to 3. Now if 0 to 3 via 2 if we move, what will be the cost? That we are going to calculate. 1 plus, here 2 to 3 it is 2. So 1 plus 2 it is 3. Now assume, now whatever 3 is there must be compared with 5. This is very much important. Now we are not leaving at first table only. One second table, how the value will change, you have to observe carefully. Now again, the whatever the 0, 2 via 3. Now 1 plus 2, that is 3. 3 will be compared with 5. 5 is greater than 3. Yes, 5 is greater than 3. Then what happens? Then the value 3 will be taken into the consideration. Now from node will change. It's not via 1. It will be from 2. If you reach 3, it will be nearer. So from 2, from will be changed. Now observe this particular change here, how this change is going to be done. Now this is a final. All neighbor 2 nodes are over. So like that, you have to take all nodes into the consideration. I given a one node example. Now observe here, initially the node whatever is there, it's 999. When compared with 1, it became 5. Why? Because 999 is greater than 5. And again compared with 2, if you move via 2 from 0 to 3, then it is 3, then it has been changed. Like that, from one node, you have to check all other nodes tables and you have to update that until the last table. Now again 1. What the next process is there? And again we will go to the one node. In a one node, for a one node, the tables will become from 0, 2 and 3. Again, one node table, initial table will be compared with 0 table, 2 table, 3 table. Again, it will be updated. Like this, each and every node will be keep on updating. In this way, the distance vector algorithm will work. Now we'll go to the program. We'll see there how the instructions will be there. I'll stop this sharing. I'll close this paint. Right. Now we'll go to the program. That is, we have where. Right. Now you can see here, everyone. Now you can see here what are the instructions. It is there here in this particular thing. That is include you know this the statement. Now structure. What is this structure? We are creating a structure with two variables, that is distance and from. Why you got it? Why? Because in a paint I have shown you that the distance and from, the node will represent the whatever a node will represent here, whatever a node will represent, that is zeroth node which I have taken now, like that. So until the end node. Now the RT of 10, that is of this particular nodes, 10 objects we are going to create. Each and every object will have from that particular node what is the distance and from which node it has to move to that particular node. So that details will be there in this particular thing. Now come to the main program. Now you see here, first we are entering how many nodes you want, then so we are creating a cost matrix. How you are going to creating a cost matrix? So what is the distance from node to the next node? That distance we are going to take according to the row and the column. Now you see here scanf C of I comma j, that is 0th node to 1th node, 0th node to 2 node, 0th node to 3 node. Next, 1 node to 0th node, 1 node to 2 node, 1 node to 3 node, like that. The cost we are going to take. After taking a cost, then what we are going to do? We will take RT of I, that is that RT of 0, that 0th node, whatever is the distance to the jth node, that is the next node. For example, 0 to 1, what is the distance? So that cost we are going to take, and from which node it has to move. So that we are from which node, so that we are going to take, like how I have explained. So now your RT of I means the object whatever is there, it will have 0th node will have a distance and from all other nodes. Next, one node will have a distance and from all other nodes. Then two node will have distance and from all other nodes. Now this distance and from will be there according to the object of RT, where it has created in a structure. Now coming to the next thing. Now you see here, just we are displaying the initial tables here. Now after displaying the initial tables there, means just whatever initial table of node number 0, node number 1, node number 2, like that we are going to display. After displaying, now we should go for a final tables. Before going to the final tables, we should apply the distance vector logic. Now you observe here. Do first, we'll start with a do, will take first node. Count is 0. Now from observe carefully everyone, how we are going to take this. Why 3 for loops? Always it will comes into the count. For I, j, k. Now observe everyone here. I is there, j is there. Assume that from I to j the distance is 5, and k in between node I will take, and I will add I to k and k to j, and I will compare that added value with the main value. That's why 3 for loops are needed here. So once you are going to take a 3 for loops, now how you are going to take, this is the heart of your entire program. That is the entire distance vector logic will be there in this particular thing. That is RT of I dot dist of j. That is the present whatever initial cost is there from I to j, if that is greater than cost from I to k and distance from k to j in between. Now k is a in between node. So if that plus value, whatever is there, that is the present value is greater than the added value, then what you are going to do, the present value RT of I dot dist of j will be changed to that some value, and from will be changed from j to k, that we have did in a painting. So this is a one very much important thing. Then we are going to increment count plus plus. Now while count not equal to 0, this do while will be keep on repeating. That will until all the nodes will be taken into the consideration, that will keep on repeating. Now coming to the next thing, after the final tables, according to the node, from this node, 0th node to all other nodes, 1 node to all other nodes, we are going to display the final tables. After displaying the final table, now each and every node is having its final tables. Assume, for example, what we are going to do now, we will enter a source node and we will enter a destination node. Now we have to know what is the cost of that source to destination. It should be a minimum. Now we are going to display that RT of S dot dist of D, whatever is already recorded in a objects of that node. So it will be displayed. Once it has been displayed, okay, we'll get a distance. Now what is the path from via which it should move? For that, what we are going to do, we are creating we are taking one particular array and initializing that array 0th element to source node. Why? Because from source to destination we should move. While moving, first it will be I will be the source node, the next node. When I go to the next node, that will become source. I will go to the next node. Then I will go to the next node, like that, until I should traverse until the distance. Once I come to the distance, my source node is equal to distance, then I should stop. So in this way, now array of 0, first I will take a source node, let I be 1 there. To traverse the route, that is the one. Now observe how beautiful logic it is. While source not equal to D, that is whatever your S is there, temporary S, from source I will move node by node, node by node, and I will stop at D. If it is not equal, then I should move. That's the intention. Array of I is equal to whatever array of I is there, array of I, RT of S dot from of D. Now I am jumping to the next node, from source to the next node, from of D, whatever source. So how we are, first step, first source to the which is a next node. So that array. Next, yes, what I am doing, RT of S dot from of D, I am shifting S to the that next node. So I plus plus, I will keep on doing. Now this array, what happens? Array will be keep on building from source. I will go to the next, I will go to the next, until the distance. Now the path, whatever is there, it will there in a array, ARR array. Now what I am going to do, for j is equal to 0, j less than I minus 1, that is this value, whatever this maximum value is there, that I minus 1, j plus plus, I am displaying that array, ARR array elements one by one, then automatically I'll get the path. So in this way, the distance program will be executed. Now I will execute this particular program, and we can see that particular whatever in a paint I have taken that thing we can take here, and we can see this particular thing. Now just I'll close this. Sorry. Yeah. Now cc dist c dot c. Yeah, it's run a dot out. Now how many number of nodes? 0, 1, 2, 3, 4 nodes. So 4 I should enter. Enter the cost matrix. Remember that particular thing. Now 0 to first 0 you have to take. 0 to 0 is 0. Sorry, 0 to 0 is 0. Next 0 to 1. 0 to 1 is 1. Correct. Then 0 to 2 is 1. Correct. Then again 0 to 3, that is 999. Correct. Now coming to the next. What will be the next one? That is 1 to 1 to 0. 1 to 0 it will be 2 or 3. No, I think it is. Now what you have taken? 1. Let it be 1 only. Right? Now next, 1 to 1, it will be 0. Then 1 to 2, let it will be 2. Then 1 to 3, whatever value we have taken, 1, I will take 4 here. 5 because of that. Right? So then, now come back here, second value. 2 to 0, it is 1. 2 to 1, 2 to 1, whatever, 1 to 2, whatever is it, 2. So same thing you have to write. 2 to 1, it is, yeah, 2 to 1, it is 2. 2 to 2, it is 0. Then you have to write 2 to 3. What is 2 to 3? We will take 2. Correct. Now, enter this. Whether it is asking 0, 1, 2, yeah, 3 I should enter. Correct. Now, wherever 3 is there, now 3 to 0, 999, coming to next 3 to 1. What is 3 to 1? 1, 2, 3, it is 4. Right. Then 3 to 2, that is 2. Then 3 to 3, that is 0. Now I think it will. See now. Observe here the distance. First, we'll see that zeroth node where it has. 1 minute, just yeah. Now observe here, 0 source node is 0, and the distance is 3, and it is via 2. This is our intention. Right, we have seen that. Now come back here. I'll write this here distance node is source node is 0, and destination node I'll take it as a 3. Now we should get a path 0, 2, 3. Via second node it should go. Done. So we got an output, correct output. So in this way the distance program will be executed. Now I'll stop this sharing, right? Now we'll back here. Now, so because of your request, I second time I am doing this particular program. After doing this, and now I will upload this to the YouTube, and you can view this particular. Thank you very much.